Hello, Kenny.
Hello.
How you doing?
Oh, pretty good.
Good to hear that. And uh, just want to remind everybody that next week we have no sessions. Just I think you know already, but I just want to remind everybody because I'm heading out. I have my 25th wedding anniversary, and as a consequence, we have no sessions. So the sessions are already scheduled, but for future dates, that is already populated on that website. Should have the dates. I hope I'm not surprising you. Just checking that this is known. Because I did publish that. Is it known to you?
Yeah, I knew.
Okay, good. Just want to make sure that everybody is aware of the fact that we do not have any sessions on these dates. So the next one after today's will be May 14th. I just want everybody to know. Okay, let's start. So last time we were discussing something about Netflix, and I hope you can see my desktop. I am writing on my desktop, so checking that. And then I'm opening up my notepad that I was using the other day, which has a design, which is an Amazon recommendation on how media sharing applications could be deployed as a reference architecture in the Amazon cloud. That's what we were discussing the other day. And so we'll continue that discussion, finish it off, and do some live demonstrations of this auto scaling business. And we'll talk some more new concepts and new tools about how to make auto scaling work for you in your applications that you might have. So let me remember what we were discussing the last time. I think we were talking about Spot instances. We discussed 2 or 3 different types of pricing model. One of the models was Spot. The other was on-demand pricing. And a third model of pricing was, what was that called? In Amazon, they call it reserve pricing. Reserve. And other clouds will call different things by different names, but the concept is basically 3 concepts. One is in my language, I call them retail price or list price. List price. The other one is a bid price or an eBay style price. And the third one is a contracted price. A contracted price, meaning it is negotiated price. You negotiate with them on a term commitment, a 3-year term, 1-year term, something like that, and you pay some amount, let's say $40 or some token number. Here in an eBay price, you might get it for $30, and the list price might be something like $100. I'm just figuratively saying a relatively token representations of some arbitrary price sticker, $100 sticker, will get discounted down to roughly about 30, give or take, in the eBay style bid pricing, and roughly about 40 in the contractual negotiated style for a long-term commitment. That's the kind of pricing structure you see in most clouds. They call it different things, call these 3 things different names, but it doesn't matter. That's the concept. Okay, so now what I will do is move on the chart, on this diagram that we have, and discuss further aspects and just make sure that we conclude our discussion that we had on this topic. So I am again grabbing my pen and removing some of these markings and focusing on the other aspects of this illustration. So now let us look at the illustration, which basically primarily involves uploading action and then processing action. But now we need to understand what that processing actually does. What is a typical processing? What does it look like? So as an example movie, let's say Infinity War movie comes in the raw format. This comes in from your DC Comics, Marvel Studios, like that. And so we have that raw file available. We need to create a movie for every every different type of device that we plan to support. And that can be a large matrix of variables to deal with, like different resolution ratio, different resolutions, different aspect ratio, different audio codec, video codec, like that. And that is something that you already know, that these are the variables involved in transcoding action from here to here. And that is a ton of work. And by the way, to help with this action, there are open source tools available that will do this thing. And do you know of a very well-known transcoding library? Anybody knows that thing that will transcode this thing? What is it called? So this is the very well-known famous library that does what we just discussed. It is a complete cross-platform solution to record, convert, and stream audio and video. It will do that. It is available for download from here, and it's available on source code in GitHub, and a bunch of other platform packages are ready for use. I think it's not on GitHub. It is on a Git repository. They maintain their own Git repository, but it is available through Git. So you can clone it and use it. The builds are available for all these 3 operating systems. And using is kind of simple. It's right on the front page. How do you use it? You run this command line. So ffmpeg, give it an input file in the MP4 format, and simply expect an output in another format. So input one format, get it in another format. That's how the overall structure is. It is fairly extensive in its documentation about how to exactly choose the input format and provide an expected output format. You can basically dictate, and the documentation will guide you how to use it. It's mostly command line driven, and you can just invoke the tool and do a bunch of things with it. So that is one of the tools that is useful under the hood. On the command line, you can run something like, look at a video file that you might have here somewhere, and say ffmpeg input file, some file.mp, some maybe raw format, and output file in another format like that, mp3. And it will produce the output pretty much just like that. Although right now it will say that I don't have that file, which is, I don't have, it's a random file name. So that's why it says no such file or directory, but it's fairly easy to execute like that. And so using this library, there are many applications and many services available on the internet. One of the not so well knowns is encoding.com. It's a software as a service. What it does is what I just described. Is you basically give these guys the input file, and they will take your file in any cloud location, public cloud, hybrid cloud, reserved cloud, whatever other cloud, and produce the output for you. So the media services, you can see what they do. If you click on the supported formats, they will have all these formats supported, input formats, and you can get an output in any format you like. Like here are the list of video encoding formats, the results in these are the codecs used, bitrate, selection, image formats, closed captioning, audio formats. Sorry, what just happened? Hello. Yeah, closed captioning, audio format, image format. So bunch of variety of capability already provided as a service so that you pay these guys some money on every conversion, and you put your, or maybe a flat fee, like $199 per month, something like that. Flat fee, you give it to them, and they will expect you to provide them access to your bucket of some sorts, where you will keep your video sources. So you will give them access to the bucket. They will take it from here and process the output and put it back in your bucket. That's how they operate in your bucket. So you give them a source, they give you the output. So basically, they're doing the processing for you. Netflix will do their own processing, so they don't want to have it outsourced, so they built their own. They've been doing this for many, many years before encoding.com came along. So Netflix doesn't need this service. They don't. But other people might need, so that's why you have this service available that is from some price. Like usual, other people will compete and they will come up with their own solution sets. So if you look at AWS and coding solution, Amazon has their own service here. It is called the Elastic Transcoder service. It is available as one of the services in your Amazon cloud. If you log in and you sign into the console, you will have it somewhere listed. So they have a large collection of services. And so one of them is this service, transcoding service. So let's go find out where it is sitting, somewhere here. And it's hard to find. There are so many services with Amazon. It's like, really keep track of what is where. And so somewhere here you will find transcode. Let's just search for it. Transcoding, there it is. Media services. That's the section. So Elastic Transcoder is one of the services that they will transcode for you. And so what do you do here? And again, Netflix does not use this service. They have their own. So you create a new pipeline. In the pipeline, you provide basically a place to put your input, and they'll give you the output. The way you do that is through a bucket. So you configure an Amazon bucket for transcoded result, and you have a bucket for thumbnails, and you basically invoke the pipeline. They charge you some money, and they transcode it for you. And that's the whole idea behind this this concept of pipeline. Okay, so we have, imagine now in our repository, imagine that we now have for a movie like this, in whatever Infinity War movie, we now have the transcoded results available, and they are ready alongside our raw file in our bucket. So we now have in our bucket, this is the source file, and then we have a bunch of output files in a variety of form factors, shapes, resolution, sizes, bitrate, codec, this and that, all that matrix of variety of files. So let's simplify this a little bit. We'll call this infinitywars.raw file, infinitywars.iphone format, .mp4. this is not the right syntax, but I'm just saying it like that. Infinity War movie iPad format. Infinity War for Surface laptop. Infinity War for Sony TV. Again, these are made up names. That's not how they will actually name it. But for the purpose of discussions, I am just using this name, Samsung 4K TV, like that. So imagine these are the names that we have in our bucket. So in that bucket, you now have these files sitting, the source as well as target output files available in our bucket for this movie. And we have to do this for a zillion, I don't know how zillion is a word or not, but I'm just talking about this long tail collection of movies. Long tail. And this is like a worldwide collection of movies available with Netflix. Not the head, but long tail. So all these movies that are so popular are not so popular even today, but some of them are still popular. So people occasionally watch it. And these movies are available in all these encoded formats in our bucket. Okay, Now let's understand a couple of other things behind the scenes as to what will be needed for a complete implementation of a scenario that I'm going to describe to you. I'm going to change my sheet of paper, and here I will now talk about a user scenario. The user scenario is as simple as how will a user use this stuff. So that's what I'm trying to accomplish here. What I'm saying is, now you have a user. Imagine that user is a typical teenager. So the teenager is watching their TV, Samsung TV, 4K. And that file we had in our bucket, in that bucket we had a file called Samsung 4K TV file. We also have the iPhone file, and we have the iPhone file and the iPad file, and like that. Other files are available in the bucket. And he's watching, Deadpool #1, the last years, a couple of years ago. Oh, it's an old movie. It is there, and he's watching that one, and that is playing right now on the 4K TV. And he's watching it, and it's like a 2-hour, 32 minutes movie. And so he's watched it into about 59 minutes into the movie. And now he wants to, go with his parents. And they want to go out for whatever. They're just going to Seattle, for example. And so exactly at that 59-minute time frame, they pause the movie. So that movie is paused. And now imagine the experience as seen by this teenager. The expectation would be that as soon as the teenager is now in the car, in the back seat, and he has his iPhone with him, and he now wants to watch that movie again. So he starts that iPhone, opens up the Netflix app. The app shows this person that he was watching this Deadpool #1 movie already. And he just happened to have paused the movie at 59-minute mark. At that point in time, timestamp, he seems to have paused that movie because that's what he did. But the fact that you have to keep track of this thing about that particular user is something to note, is that you need to make sure that the user, this teenager user, paused it here and now wants to resume. So now my question to you would be, what does it really take for a system of this type in the back end to make sure that this kind of an experience is given to this teenager user, where they pause a movie at this point in time and they change their vehicle, or rather the target device, and they're now using a different device. They still log onto the same account. They expect this movie to pop up on the screen with a resume button ready to play from that point timestamp and beyond. Now, if that's what we want to have the user experience, what do you think needs to happen on the back end? That's the question I have for you. So go ahead, describe. Anybody? Or nobody? Let's see who's here.
Can you ask that again?
Okay, the question is, if you have a user, like teenager, pausing the movie Deadpool #1 on a Samsung television, which is a 4K TV at 59-minute timestamp, pretty much like I go to the YouTube, and in that YouTube, I find out one of my videos, and in there I have this video. Where is my videos? I don't want to play anybody else's video because it's going to be a problem if I am recording. So I can play only my videos because then I don't care. I don't want to get into copyright troubles. That's why I'm very particular about videos that I own as opposed to other people's videos. So what I'm saying is, where is that? Where is my channel? There we go. Is it my channel? Yeah. So this is my video. Okay, now I can do whatever I want with it. So I'm watching the video, and I pause it at, let's say, 59 mark, right there. So I just assume this is the mark. So I pause it at that point. Okay, then pause it. Now I change the device. What do you think needs to happen on the back end for the same video to pop up on my iPhone when I suddenly change from my Samsung TV to the iPhone, and expect the same video to resume from that point time in that timestamp and onwards? See this video? That should pop up at that point in time, wherever I paused it. So maybe it is this time, something like that. So pause it at that time, that's how it should pop up and resume from that point onwards. On the back end, in the cloud, what does need to happen on this company that is rendering you these experiences on this movie and the same movie here and on the iPhone and on the Samsung TV, and you just decided to change the device. The user decides, I need to go. I want to drive or get driven. I'm on the back seat. I still want to watch the movie to finish it off before the dinner starts.
Well, you'll need I would assume, a database or some sort of data repository that keeps track of where you currently were and what device you were on.
Yes. Data, you need to keep track of what the user activity is, right? And that user activity needs to be kept track on, as you said, a database. So in here, let's go look at what that database is. So if you have this data store, it needs to carry a ton of data about, not only about the movie itself, but also about every single user. Now, a user is something that I want to now look at. Earlier, our user person here was a person, think of it as a Netflix employee, Netflix robot, trying to upload movies into the system, and it was uploaded, and it was processed, and it was sitting in the bucket. Great. So now this segment, all these black colored items, they are the Netflix internal systems, or other systems dedicated to use by internal people. Now what I will do is look at the other colored items, which are not so black colored, but slightly gray colored, and they are primarily systems designed to be used by people who are outside the company, like these guys, these units here and here and here. They are primarily designed for use by actual customers. Now imagine the same person that was before Netflix bought is now the teenager I'm talking about, or maybe it is you or me. And you and me, we are going to open up our Samsung television. The TV is right there. Now this TV, when that user logs in, has to first of all do a DNS query. The DNS has to take this request over to some load balancing endpoint, where you actually get presented with the experience rendered by a web server that is showing you through a load balancing system, where the user is expected to see what they see when they log in on netflix.com. By the way, this screen that I'm showing you right in as soon as it shows, this screen is not that screen. It is a different site, not this site. This site that you're seeing right now is the marketing site or sales site. As soon as you log in, at that time, you land on, not now, maybe that's not the right password. So maybe that's the password. Yeah, so now as soon as you log in, then you land on this endpoint at that time. Before the login action, the site that you see is not this site, but it is something different that they don't show you in this picture. It doesn't exist. It's a separate site. It's an e-commerce marketing selling site. Once they are sold, then they are serviced, and they are provided a way to access the movie content through these web servers. And that is this site when you see who's watching. So it is going to be me watching. And so I select my profile, And then I see these lists of movies, and maybe Baby Boss Back in Business. Hello, hello, don't play. Shut up. Okay, so yeah, these are the movies available, right? And so here you get to experience a selection of movies. Now, where is this data coming from? It is coming from this data store, where these web servers are pulling information about whatever is presented to the user. So there are three users that you saw when I first logged in, and it showed me, my wife, my son. Those three names popped up, and then I selected it's me, and then I was presented with the experience that I expected, which is a list of movies I want to be able to watch, and that list is coming straight from data source. This list contains information about Deadpool, number one, which is an old movie, and the movie file is already sitting here. And information about that file and all the other formats available to support that particular Deadpool number one movie is also stored here. And that information about the movie itself is stored in this data store. And that is all the data associated with the movie, which is what you see, for example, in Rotten Tomatoes. So let's go see Rotten Tomatoes, and you will find here Deadpool, the movie. And here, this movie, 2016 movie, you have information about the movie, like the album art, a little trailer, the picture here, the photograph that you see, and a trailer might pop up. You have some other additional trailers, and you have movie info about what the movie is, what the genre, directed by, written by, what the date of release, the date of on disc and streaming date, the in theater date. You see, the date in theater versus date in streaming are different. The streaming date and DVD date is slightly later. And then you have cast, and you have other details about and critiques of that movie. And this is the information all about just one movie. All of that information is stored here, along with all the corresponding files in that particular bucket. And you have this for every single movie that you want to be able to show to your customers, that is listed in this screen. You see a ton of movie content. It keeps on growing. Every single day there is a new movie popped up in Netflix. It is here. Now, our movie that we were talking about a while ago, or rather the day before yesterday, it was not this Deadpool number one movie, by the way. It was another movie. So we'll talk about that also. But I want to finish off this discussion regarding the synchronization of timestamp. So the idea here was that this person, when he or she watching the Samsung 4K movie video and into 59-minute timestamp, the person then changes over the device, not Samsung anymore, but iPhone. At that time, the movie experience should continue from this point in time onwards, all the way towards the end, until the user decides to switch the device again. So the transaction will happen something like this. The movie will play on the 4K targeted file format up through to this point, and then the remainder of the movie will play in a different target format. And so the target format selection will actually switch from one selected target device to another selected target device, depending on users' actions. So the system has to keep track of what the user is doing, which point in time, what timestamp, and there are a bunch of other characteristics involved in making sure that these things actually work out. There is a similar system that is available these days in the market. That thing is known as WhisperSync. Have you heard of this thing, WhisperSync? Anybody? This is a product from Amazon, not AWS, but Amazon. Amazon.com. It's not so popular. That's why people don't hear about it much, but let's go see what it is. I think it is relevant to discuss that. WhisperSync. The idea here is that you have something even more difficult than what I just described. The idea is, let's say if you have this book called Maybe this is a good book. Let's say 7 Habits of Highly Effective People. And that book is available for purchase. So you can read it for free if you're a member of the Prime member, or if you're not, then you can buy it, buy the audio, buy the book, buy the Audible book also. So imagine if you actually buy the Audible book alongside. Let's first check whether WhisperSync enabled or not. I don't see it quite here. Why did it show up? WhisperSync. I didn't even land on the right page. What's up with that? WhisperSync per voice. Find your match, add narration. So they're discarding or stopping that service or what? Yes, easily switch between. Yes, that's the value proposition. So here the idea is that you can seamlessly switch between reading and listening on with WhisperSync for voice. The concept is that they don't seem to have a ready example for me to show you. But this idea is that if you have a book, let's say, the book I mentioned, like the Goal book. And if you buy that book in the Kindle format and you're reading it on the Kindle device, and you are read into up to page number 53. You read all the 53 pages from the first 1 to 53. You read all that. And you still have a lot more to read. There are about total of 356 pages. And you read 53. Now you decide that you want to drive to work. So you still want to read the book, but you have purchased the audiobook also from audible.com. The same book available, The Goal, purchase the audiobook, The Goal book, and you start your Audible app on the iPhone. You connect it to your car's Bluetooth system, and you are now in the car driving. Now you get the idea that you want to actually listen to the remaining book. And as soon as you jump into your car, you press the play button. What do you expect to actually hear when you are selecting the Goal book for playback? And what WhisperSync will do is it will somehow figure out that you have read 53 pages into the book already. And so you can probably complete my sentence as to what will that be if you don't know about it, even if you don't know about it, because it is intuitive. The intuition comes from the fact that you are going to map the reading versus listening action of the same book in all the number of pages, 356, translated to about 7 hours. And here is page number 53 that you read already. And this will translate to something like maybe 1 hour, 52 minutes. I'm just making these numbers up. And so as soon as you select the Goal audiobook in your Audible player and you play the play button, it will start playing from not here, but here. And it will remember that you have already read into 53 pages. And then you drive and you reach your office. Then you stop your Audible player because you want to go inside and work. And then you work. And then in the evening, you are like, getting bored and you want to read again. And so you are back home, and this time you open the Kindle app and you are presented with this page number, 232. And that's the page that opens up and you can continue to read. That's the idea behind WhisperSync. Have you heard of this thing before? The read action, the listen action, and the read action. Did you know about this thing already or not?
Yeah, I knew about it from my Kindle.
Okay. So have you actually experienced it?
Yeah.
Does it work?
Yeah, it does.
Okay. So the tricks that go in making sure that this actually works are kind of very strenuous in that, you know, you have to keep track of how many pages it has and how does it translate to how many minutes per page in the audio format. And this transaction has to be somewhat kept in sync, in that the user experience need to be kept intact. And that's why you have to purchase the book in the Kindle format as well as the Audible format twice. You have to pay for the same book twice, which is kind of expensive. But people do it because they like the idea of being able to do this whisper sync method. And that's the concept here, which is similar to what you're doing somewhat, in that you watch it on one device and then you switch over to watch it on another device. That's the concept from a video watching experience when you're changing the device or the target where you're watching that particular movie versus you reading and listening. This part is slightly more complicated because of one more reason, which is you can actually make this number of pages change based on the font size you select in Kindle. So the page number of pages can grow and shrink depending on if you're big font or small font. That becomes another challenge to keep track of. So there is a lot of math and a lot of data involved in keeping this and this action in synchronization in the Whisper Sync application. Now, back in our Netflix discussion on the picture that we were having here, this picture, what we want to be able to understand is a couple of other things related to the entire Netflix movie watching experience, which is another question. How many times have you actually called Netflix complaining about the fact that their movie is not playing? Most of you, I'm suspecting, are already Netflix customers. So the question to you is, how many times have you actually called them that, hey, Netflix, I'm on your phone call and support service, and your Netflix doesn't work? Does it ever happen?
Never.
Why? Why does it never happen that, hey, it always works? What's going on?
Magic.
Magic. No, it's not magic. It's not magic. You know there's not magic. There's something going on. A couple of things that is one of the first very, very important things going on is that every time this user that they play or just get hold of their device.
Because it's on cloud, that's why.
No. I know. Yeah, cloud is, yeah, whatever. But the point is Netflix does a whole lot of things behind the scenes, even before you actually start using, or rather actually watching their movie. They collect a ton of metrics, a ton of data about what you are doing with the application, with the device in hand, and about your connectivity, about your bandwidth, about your latency, about jitter. And I'm going to write these things down for you so you don't forget. So they look at the total available bandwidth between your home and your nearest Netflix endpoint. So that end-to-end traffic that has to flow in between, there is Comcast or other people in between, and then eventually they reach the Netflix location, wherever that cloud location is. And so you have to keep this entire bandwidth from your location all the way to the endpoint where the Netflix is rendering its service. So the rendering happens through a CDN, by the way, where the movie is getting picked up from the bucket and is rendered directly to you, like that. This interface of web servers is more for selection, allowing you to carefully select which movie you want to watch, and then the control is handed off to to the CDN, where the actual CDN will grab it from the bucket and deliver it to your device. So that's the end-to-end bandwidth needs to be measured for. How much bandwidth is necessary for a transmission of a particular video to your target device? That bandwidth will fluctuate up and down quite a bit, almost every single time. You will measure bandwidth. Bandwidth measurement is typically known as speed test in simple language. Speed test. So you measure a speed test, you will find that this number changes every single time you run the test. And that is fluctuating. Now it's a fairly high speed I have, but it can change. It can go down any moment. That's how internet is. It is very, very unpredictable. And so the thing to remember is that Netflix is actually not only measuring bandwidth, but also measuring latency. It measures jitter, which is it's a metric of how regular or how predictable the traffic can be. So the actual the metric for jitter is something like this. Let's go see. The word jitter is described as slight irregular movement or variation or unsteadiness, especially in an electrical signal. That's the dictionary definition. Now let's see the electronics definition of what Wikipedia describes. So Wikipedia will have a better definition of jitter. And jitter is the deviation from true periodicity of a presumably periodic signal. So this can be shown as a periodic signal. It happens every so often. And sometimes it happens faster than usual. Sometimes it happens less faster than usual, slower than usual. And then that variation is the jitter. Now, variation can be bad. It can be catastrophic in that if you notice, if you're traveling on a highway, it's a one-lane highway. So you have cars here and here and here, and all of them are moving at the same speed, everybody at 65. No problem. Traffic flies easily. But if you have a car here that happens to be driving faster than usual, I'm saying faster, you will find that the overall speed of the network, or rather overall speed of the traffic in that particular single lane highway is slower. Have you seen that? One guy running around faster than usual can cause the entire traffic to slow down. Have you seen that? Or no, maybe not.
Ted, what was your question?
The question is, if you have a single lane traffic and you have one person who's driving faster than the limit, can slow down the whole traffic.
If they get into a crash, I guess.
Yes, that happens all the time. So the idea is whether you go faster or go slower than everybody else at a predetermined rate. It is not, if it is not predictable, the overall speed is slower. That's what jitter essentially does. So you have to measure jitter, you have to measure latency. Latency is basically the amount of time it takes for a packet to travel from here to here is the measure of latency. You can measure it through ping. And so you measure the ping times, you measure the bandwidth, measure latency, and a bunch of other characteristics like the device capability of the device they're using. Devices capabilities, meaning can they produce, can they, what resolution, what form factor, what codec support, what playback support, what kind of energy requirement does it have, what kind of network capability that device has, which is basically these things, again, on the top, these things. And they might vary between device to device, even in the same location for the same user. A phone may be having a smaller, slower chip compared to a wired connection to the television that the user might have. So the device, between devices or for the same user, performance of network can differ. So when at some time when the network performance fluctuates, what Netflix does is drops the rate at which your media is traveling to you. The frame rate at which the movie is sent to you is dropped. The bit rate at which the movie is sent to you is dropped, and you will not notice it. The fact you don't notice these things is because of human eye can detect only when it is below 24 frame per second. If it is below that number, you can potentially detect that the actual flow of traffic is kind of sluggish, or is like a slow scan TV, or looks like a old movie picture where you're showing photo after photo of still picture after still picture showing in a rapid sequence. And so it looks like old 1800, 1900 movies. slow scan TV or 1800 movies. So old style movies, that's what you will see when the rate of frame drops below that number. So Netflix has to make sure that they do not drop below that number. And if they do drop, if they have to actually drop below that number, then they will not send a 23 frame per second video at all. Instead, they will tell you your internet connection sucks. And they will stop playing and ask you to contact Comcast or your ISP. They contact your ISP because your internet connection is flaky. So I will not play it for you. I'll stop the video and make you put the blame on the other people. So you call Comcast and you ask them to fix it, and they're likely to take the trouble because they are usually bad. Not most of the time, but many times they're bad. They're bad because of the fact that they are Comcast. Comcast is a company that is known for its great customer service, so much so that people have surveyed the best possible customer service, or I should say, the worst possible customer service in the US. And Comcast was, of course, number one worst customer service was Comcast. And the number two worst customer service was the Internal Revenue Service. What does that mean, really? It means that people will gladly get audited for income tax than call Comcast. That's what it means, practically speaking. But that's how bad Comcast can be. But that's what Netflix does. It will stop sending your signal, and that you may see that other similar behavior from other companies. For example, this company, YouTube. You play the video, and at some point you will find that the video transmission is bad. The YouTube will drop the signal, or rather drop the frame rate, bit rate. They will shrink the bit quality by doing something like this. Instead of sending a 4720p, they will drop it to 480p, and they just change the file on us, and we can now adjust the quality settings to 240p or 144p. The quality will be really bad. You can see that it's already looking bad, but that's what you can get by if you have a small handheld device with a really small screen and a 2G connection. That's what the automatic adjustment of bandwidth will take effect on a small handheld device that you're driving around with, and you have a very flaky internet connection. They will adjust. Now, Netflix will never do 144p. They will probably not go below 720p for most modern situations because movie watching expectations are very high. People have good expectations, really at least 480p HD expectations. People have that. And so you'd never see this kind of a lower resolution selection in Netflix. In fact, you don't even see these buttons. You see them only in YouTube and some other places. But that's what is dynamically done for you. You don't even have to go and select and adjust your quality by yourself because Netflix does it for you. You don't even notice. And so adjustment of automatically adjusting bandwidth available and the appropriate quality of video rendered to your device is adjusted on the fly without you asking for anything. That's why you don't seem to call Netflix, because it seems to just work. Occasionally it will just stop playing, and you will notice that your internet is broken, and so you call Comcast or your phone company and you have them fix it. So you basically put the blame on other people and not blame Netflix. But there are cases in which even Netflix can be bad, and that is just fact. Anybody can make a mistake, and so the reason they tend to make less mistakes than most other companies is because of certain things that they do, which apparently is magical. And I'll show it to you if you haven't seen that. They have a page dedicated to tools that they use on GitHub. And they have a thing called, where is that? They have a lot of monkey business. Literally, it is called monkey business. And in fact, the name is Simian Army. So the word Simian Army is the collection of tools to keep the cloud operating in top form. So that's the tool set. Tools for keeping your cloud operating in top form. And one of the items in this army of simian means basically monkey. Like feline means cat, or canine means dog. Simian will mean monkey-like creatures. And so this simian army is actually a collection of monkeys. And one of the monkeys here is the chaos monkey. And chaos monkey is a resiliency tool that helps applications tolerate random failures. Let's see what this thing does. That is one of the reasons there's a newer version of Chaos Monkey available as a standalone service. So you can take that Chaos Monkey and run it. But what this Chaos Monkey does, as you can see from the title top line, is that it is a resiliency tool that helps applications tolerate random failures. What does that translate to? It translates to something like this. Imagine you have your services running in some location, and you have some kind of a network running and some machines running and some things, stuff running. Stuff is a good word. So let's say these are the things that I'm running, and I have them, and then I have a bunch of them. And what I will do now is grab my simian monkey, the chaos monkey tool. This is my monkey, and I will have the monkey give him a sledgehammer, big sledgehammer, and have him or her, whatever that thing is, let loose on my cloud, like literally go create havoc. What this simian monkey tool does is it randomly shuts off machines. Like literally take a machine, I decide to take this machine, and I just decide to, boom, gone, and randomly pick anything, gone. That's what this simian monkey does. Now imagine, would you allow such a monkey in your Boeing data center? Just asking. They run it by their choice. They deliberately make this monkey let loose in their Netflix data set, in the Netflix cloud in Amazon. Let it loose and let it cause havoc by themselves, as opposed to me asking you, hey, would you run Chaos Monkey in your Boeing company? That's the thing that have you heard of this thing before, like Chaos Monkey business?
Nope, first time.
Okay,
Yeah, I've heard of it.
Okay, so this monkey basically is a tool to improve resiliency in your setup. So by doing such unpredictable disasters in a planned manner, when you have a machine just disappear out of the blue, what you're really designing your application sets and your services for a system that can actually handle real failures when they happen. So you're not waiting for failures to happen, you're creating them yourself. And so by doing that, by doing that in your real production setup, you are already creating and living in and developing in an environment that is designed to handle failures. Because you're creating failures yourself, you're not waiting for disaster to happen, but you are causing it yourself at a higher rate than is actually possible, or rather, usually seen. A natural disaster might occur only so many times. You're deliberately causing more failure than usual, and thereby preparing yourself for a disaster-proof operation. By doing that, what you are doing essentially is improving the overall reliability of a service. And you're making sure that your end user, this guy, doesn't notice a thing. They can keep on accessing whatever they're doing. They don't notice. The beauty of resiliency is not that things do not go bad, but the fact that your users do not notice, or even if they notice, they do not care if the things go bad. That's the point of providing a service that is highly available, so that the users are happy no matter what. They might know that this machine is down, but they don't care because the other machines are available and they can get by They can operate their services. They can operate and access their things. This one is down, no problem. Even this one is down, then they have this machine operating. They can get by, do their things. In fact, most of the times, these machines going down is transparent to the user. They are just gladly happy with what they have. They don't even know that disasters are happening. And that is exactly how you should plan for disaster, is that your user should not be aware of the fact that you actually are running through a problem, because they should not be impacted. And then they are not impacted. They don't care whether you have machines dying or not. So that's how you should design. That's one of the reasons why you see that you see that Netflix has a collection of such tools that will improve your resiliency of your applications in your back-end cloud setup. Chaos, they have a full library available, I think, on this page called netflix.github.io. You should read these things, and there are a bunch of other tools also available that are kind of useful. And they have recently announced a product called, I think I mentioned it the last time, it's called Titus. It is comparable to, not this Titus, not this, the Netflix Titus. So Netflix Titus. This is comparable to Kubernetes, and that is now open source on the April 18th. So fairly recent, late last month. And that is, this container orchestration is now open source. So they're doing it, they're providing open access to other people, so other people can learn from it and make use of. That is one of the reasons why I go into detail of this Netflix as a case, as an examination point for us to discuss as to what is going on under the hood. There are other things that we will also discuss in the context of a variety of applications, but I think we have discussed Netflix enough. If you have certain particular aspects of understanding this idea in further detail, please let me know. Otherwise, I will like to actually do another live exercise in which I would like to show you auto scaling in action. So that's what I plan to do. Unless you have a question, I will prepare for that, and you can see me in a real live example how auto scaling will work for us. By the way, just finishing with this idea, web servers are also auto scaling here. You have the load balancer in the front, and this auto scaling group will grow and shrink depending on how many users are hitting the service and accessing the data store, accessing the media repository, and are delivered the video watching experience that they expect. So this is a growing and shrinking, automatically scaling setup. This piece is the user-facing piece. These pieces are internal company-facing segments. So I will now switch to the Amazon cloud and see if we can get to an auto-scaling setup. So let us see how we can make that happen in a live demonstration. What I want to do is bring up another tool to make this thing a little bit easier on me. And the tool I want to use for this demonstration is kind of clumsy to understand. That's why I would like to describe the tool itself a little bit before I jump into it. It is clumsy. It is clumsy because it, let me just show it to you. So imagine you have this cloud, and in that cloud you have done a bunch of work and set up a bunch of things, and you now have the setup ready and running. And you seem to be happy. And you did all this work manually by clicking through mouse and typing things and connecting dots and doing this and planning that and putting applications and making them run, and then you have it running. Great job. The problem is you did it manually. So now if I ask you to do this again, the same setup, how will you reproduce? Do you know of a method where you can reproduce the thing? Do you know already of such a system where you can do exactly reproduce? Exactly reproduce whatever you did here. Imagine it goes away. For some case, some disaster happens and it just, boom, gone. Now what do? You again do this manually? That's not a good idea. So what do you do? What kind of tools do you run? Not manually. You want to reproduce this thing. So what do you do is you use tools. And so you don't want to use manually, you create a setup. And when I'm doing this thing, what I'm really talking about is an exercise we did manually, which is, I think, I want to remind you what I'm talking about. If you're not super clear, is this exercise we did in cloud technologies where we said data center in the cloud, and we began creating a VPC and bunch of little details, right? Apparently, I have to buy the course before I can access it, which is interesting. So come on, log me in. There we go. So I think I have logged in. So I should be able to access the course, like right here, and refresh. And then I pass the course. Okay, so that's the course I'm talking about, virtual private cloud and all these little videos that you have done on your own using mouse clicks. And we did that exercise. So that as a result, we had a complex private cloud setup. What I want to do is, you created this by hand. What I would like to do is, somehow export it and save it in a folder. Can I do that? Can I do that? That's exactly what I want to be able to do. And yes, I can. There is a tool for that. And so that tool to save everything that you created in a cloud into a folder, specifically in a JSON file. For that, there is a tool. The tool is available from this cloud called Amazon Web Services, and they call that tool CloudFormation. The tool itself is available somewhere here. Where is that? CloudFormation, formation, right there. So this tool, CloudFormation, will export and give you a JSON file. The JSON file will basically keep an export of whatever you did manually first time, and you save that. Now that you have the JSON file in your computer, and when a disaster strikes, like this thing goes away, or maybe you just want to give it to your friend and have the friend recreate whatever you have exported in your JSON file. And so you want to give this file to your friend, to your coworker, and say, hey, you, just like I exported, you apply this design to the cloud. And so you take that JSON and tell Amazon, hey, take my design and create. So Amazon will just create the whole thing that you had. And it is now running. And that idea of application, like apply my design and get it to create a new VPC and run all my applications, is the reverse process of the export process. Now, these export and apply are words that I just made up. They have different ways of expressing the same idea. They call it something slightly different, but same concept. You export the cloud, you save it in a file, you apply that file to a cloud, and it gets up and running. So this export action requires another machine here, separate from your cloud. When you have this created first time, and when you want to now export your design, your creations, you need to run the process that will actually export, which requires a separate machine different from the cloud. That VPC that you create. So you have to have a separate machine, and that machine will look at your entire Amazon account and export the whole thing in a JSON file. Now, in order to create this machine, what Amazon does is gives you a JSON file and have you run that to create that machine, this one. And then you go to this machine and say, go to my cloud and export it, please. And then they will give you your JSON. This is the machine specific JSON. This is your JSON. So that's the kind of, I think it is a little convoluted to understand what's going on. That's why I just draw these pictures to help people understand what we are going to do. Is we are going to ask Amazon to give us a JSON to create this exotic special machine that will run again in the cloud, but then it will look at your cloud and find out what do you have and then export. That's the kind of setup that you will be seeing in this export business. And once you have your JSON, you might want to reproduce your JSON in the context of cloud. So you say, you know what, take this JSON and apply. And then you get the same exact replica. So that JSON I'm going to get from Amazon and say apply, and I will get this machine. Right? That's the concept of CloudFormation as a tool. So I will be using this CloudFormation tool to help me get set up and ready with a auto scaling setup, for which I will be using a ready-made JSON file, and I will say auto scaling group JSON apply. And then I will have a ready-made setup that I will be able to use to demonstrate to you the idea behind auto scaling. So in the CloudFormation tool, you have to launch let me just get to the point where we have it functional. So let me identify where it is kept. I think it is kept in a link I have stored somewhere here. So I will find that link out. I think it's in the videos here in winter 2018, where I have the CloudFormation tool in that location. And that's what I want to get to. So what I'm going to do is give you in Slack a link to a JSON file that will help me set up a cloud auto scaling group in the Amazon cloud. So that's why I'm going to give you this link right now, which is basically a JSON file. And you can open it up, see it. I'm going to open it up right now. Here's how it looks like. It's fairly long. It doesn't need to be read. It will be used. We'll use it. It's a fairly long JSON file. So that file basically goes into details about what do I need. So it will define a VPC ID, some subnets, some instance types, some constraints, an operator email and key name and SSH location and this and that, and goes on and on. Fairly extensive. Now we'll use this tool, use this JSON template as the starting point, and we'll say apply, and then we'll get an auto scaling group functional, and then we'll play with it and test drive it to see how auto scaling actually works. So to take that JSON, we have to give it to Amazon, and we'll say, Amazon, take this. So we will go to Amazon console and say, get is it this button? Yeah. So that button called create stack means create all the resources that I have in my mind written down in JSON file. So I will select a template. So I can specify a template by uploading it like that. Choose a file. I can give it a JSON file if I like, or I can choose a URL like this, or I can select a sample template. Amazon already provides you a bunch of samples. So here is a bunch of samples, and there are more samples. And one of the samples I think is the one that I want to use, which may be available here. But if I don't find it, maybe browse by sample service, browse by service. So auto scaling sample, I think, is the first sample. So load-based auto scaling as a template is the one that I want to use. And what it does, it creates an auto scaling group with scaling policy that are based on CPU usage in order to start and stop Amazon instances which span multiple availability zones. That sounds like a good template that I want to use, which is by the way the same template that I just gave you in Slack chat, this same template. I will use that template to launch a new stack. So I click that button, and now I'm starting my CloudFormer tool, in which I have specified the Amazon S3 template in the URL, which I just pasted in Slack chat. It is the same URL. That URL is basically repeating the same thing. Now, with that URL in hand, I will kickstart my tool and say, this stack, I want to show auto scaling group demonstration, and it needs to not have any spaces. And what I will do is provide a key pair. So this is in Oregon Cloud, and I'm going to select my key pair, and then my operator email, which is an email address where I will get notifications when a machine is added or when a machine is removed automatically. The idea is to do automatic scaling. So this action will involve automatic. Let me give you some idea about what auto scaling will actually do. So the idea is, if you have an auto scaling group, and we have machines and machines and machines like that, and we will be able to grow them or shrink them depending on what we do. So what we will do is we'll add load, and when we increase the load, we will expect that another machine gets kicked in. M pops up. When we reduce the load, we'll see that the machine goes away. That's basically what you will see. We'll have to load up the machine in terms of simulated customer workload. So we'll bring some load from customers and apply it to this auto scaling group. And as soon as the load hits some threshold, a new machine pops up and takes care of balancing the load like that. And more load will mean more machines popping up. And if you reduce the load, you will see that these machines will disappear. And reduce it further, you will see that the machine will disappear. That's what you will see in a live example. We will have to simulate this idea of a user coming in and loading up this machine, which is not very hard to do. It's very easy to simulate workload. So I will simulate that load, and we will, basically bring that machine down to its knees and make it loaded up 100% or something like that. And then as a result, boom, another machine pops up. And then we'll add more load if needed, or maybe we reduce load, and we'll see that the machine goes away. That's the game I will demonstrate to you live, for which I want to get an operator email, which will notify me that a machine is added or a machine is removed. I want to be able to connect to that collection, that VPC that I'm creating, from any location using SSH. I have some subnets that I want to select, 1, 2, and 3 subnets. So I want to make it in multiple availability groups, availability zones. And I have a VPC ID already in mind. So I'm just selecting my default VPC, and then I go further ahead. And here I am going to go further ahead. I think the defaults are good, so I should not worry about. Now it comes with a cost. So just want you to know that when you run this exercise, there is some cost to it, unless you are on the free tier, in which case the cost is probably low or maybe zero. So let's go estimate the cost. So it will tell you a quick estimate of what the cost is going to be. Unless you are on a free tier, your monthly bill is going to be $18.94. Now that's okay, because we are not going to run this setup for a month. It's just a few hours, so it's not a big deal. Having said, we'll go back to our setup and continue forward with creation of this entire setup. We'll click the create button. It takes a few minutes for the setup to finish, and we will see that this CloudFormation is now creating a new stack for us as soon as I refresh the page. And so here is the ASG demo stack creation in progress. As a consequence, in the Amazon Oregon cloud, you will see that I have some machines getting created and some load balancer getting created, like here. And those things will happen as soon as the load balancer is provisioning right now. Machines will come up and all that good stuff you will see as soon as the cloud formation actually takes shape. So we'll give it a few minutes and it will kick up. When that kicks up, I want to kick tires and actually cause heavy workload. So how do you cause workload on the machines? You use a stress application to simulate customer workload. That's the action I will be doing, by the way. So I'm waiting for that cloud formation template to finish its thing. So let's go see what do we have in cloud formation and whether it has completed or not. There's still creation in progress. We have some events happening, and let's see what events are there. It is creating SNS topic for notifications to me. It will notify when a machine is added or when a machine is removed. It will create a load balancer. It will create some SNS notification topics, something about load balancer, something about these things are happening. So let's give it a few more minutes for it to finish. But while it does, I'll tell you about something about a different tool that is similar to this tool. This tool we are talking about is called Cloud Formation. It is specific to Amazon Web Services, no other cloud. And that is something that I don't like about the fact that it doesn't work with other clouds. But don't worry, because other clouds have their own tools like that. They have their own tools with different names that kind of sort of function like the same. But the problem is that these tools work with only their clouds and not with other clouds. That is a problem. So to solve that problem, there is an open source product called Terraform that can handle any cloud. A bunch of clouds. Let's go see what clouds are supported while it is still doing its creation thing. So we will go to Terraform and just understand what it does. And we'll use it soon. And so this Terraform is a tool available from HashiCorp. Mitchell Hashimoto is I think he's a UW graduate, and he's a fairly recent company that has done amazing amount of work and has evolved into a great company that produces beautiful open source software available on GitHub. Specifically, this is the Terraform product, and it has 3,841 forks, and it is amazingly powerful. If you look at the product and its documentation, you will find that it works with a bunch of cloud providers. Here are some of them. The list is quite long. These companies support some major ones are AWS, Alibaba, Azure, Google, Oracle, VMware, and other clouds. And then infrastructure software. It works with other exotic things also, like network and VCS and monitoring and databases and a bunch of other things. So it can handle. And we will do an exercise using this tool next, after this one. And in that exercise, what we intend to do is our VPC creation exercise we did by hand, the Cloud Technologies VPC. We will do the same exact exercise using Terraform. In that, what I will do is give you a repository that uses the Terraform tooling, the tool that we have, and you will use that repository to basically apply the design. Apply that design to the cloud, and you will see the same VPC, the setup ready and functional. So what you will first begin doing in the exercise is to take that repository, apply the design to a cloud, and it becomes ready. Just like we are doing this repository from a template, JSON template, we are applying that right now to the Amazon cloud, and it is creating the design that we expect to see, which is, I think, should be finished by now, and creation complete. So as soon as I see the create complete, I see the output location, and there I see something as a URL. Now that URL, if I go and click on that, I should see something that is the result page. It says, congratulations, you have successfully launched the AWS CloudFormation template sample. Awesome. Now what do I do with it? What do I do? That's the question. So let's go understand what it has actually created under the hood. It doesn't show you anything on the front page when you click on that link as to what do we do with this. Like that is the link you got. You click on it and you find nothing much of interest. But under the hood, you will find that it has created a bunch of resources. So if you see the resources created, there is a listener, there's a target group, there's a load balancer, there is a CPU alarm, a security group created, a launch configuration created, a notification topic, and a web server group, and a scale down policy, and a scale up policy. And all these policies are already created. Okay, but where are they? So let's go see them. So we go to EC2, and here you will find there is one running instance right there. It is running in our VPC ID, which is the default VPC I have, and it has chosen West 2A availability zone 2A. Awesome. Now, can I connect to it, to this IP address? You bet. How do I connect to it? I go to my virtual workstation, start it up, and just connect to that location because I have given my public key already in the creation step. So it should know that I am going to connect to that machine, and I will see that the machine is functional. And I want to load up that machine. I want to put some load on it. And as a consequence of that load, I would like to understand what auto scaling will do for me when I put some load on that particular machine. In effect, what I should see is as soon as I put some load, another machine should pop up. So first of all, let's go and examine the machine itself. So here is the machine, and that machine I want to go connect to. The username happens to be EC2 user because the machine is actually a Amazon AMI. So it is not your Ubuntu machine, but a Linux, Amazon Linux machine. So that's why the username is EC2 user at IP address. IP address is right here. So I'll copy that and bring it to this location. And I should be connecting to it. And I got connected. Now that machine, if you look at it, it is an Amazon Linux machine, which means we have to install a bunch of tools for us to understand its performance characteristics. Since we are going to load up the machine, we need this tool to measure performance. We don't have it, so we'll add it. So say sudo yum install htop. And yes, so we'll install this htop tool. Now we can see the performance of the machine. You can see that the CPU performance is like 0.7%. 0% right now. It's very, very low CPU consumption. It is basically doing nothing. Okay. We'll see the memory consumption is 91 megabytes. Fine. It's basically idling right now. So I want to load it up. How do I load? I say sudo yum install stress. So I have my stress installed, and now stress is available. I will like to now use this stress application. How do you use stress? You just run stress as an example. This is an example. We can run it very easily. But before I run, I want to understand what else is done as a consequence of the CloudFormation template that has been put in place. And so we'll go and look at our load balancer. In that load balancer, we will have this thing, which you saw already in the link I gave you in Slack chat. It has this DNS name, which I gave you a copy of. It is in Slack chat. It spans 3 availability zones that are selected. They are the 2A, 2B, and 2C. So if you now draw this thing in a picture in our software, in that whiteboard, what we really have is a setup containing something like this. Let me just erase some of these guys. Okay, erase. Hello. Make room. Yeah, go away. Yes, please, go, yes. And so I have a 2A, 2B, and 2C. These 3 availability zones with me. I have machine number 1 sitting right there. And I have a load balancer. And this is your machine that we are dealing with. Let's call it M1. And we have, this is 2A, this is 2B, this is 2C. And there are 3 availability zones that are participating in our load balancer. And these are the users that will eventually come and visit your load balancer. All of them will essentially right now go here, because that's the only machine running here. We don't have any other machines. And so that's the current setup. Let's see what else we have. In our load balancer, we have launch configuration. This launch configuration decides what type of machine will be created when you need one more. You know, we have to automatically decide to grow and shrink. So we need to already define what type of machine should be created when needed. That is what launch configuration is. It defines which Amazon machine ID, what key pair, what size or T2 type, or the T2 small size, instance type, and security group selection, and all of that detail will be automatically used when a new machine is needed, and they will use this template as the launch configuration to kickstart a new machine, T2 small machine. Currently, we have one T2 small machine running already, which is in our running instances list. And there is also a T2 small machine right there. It is also using the same Amazon AMI IDE, same security groups, same VPC, except it is in 2A. The next one will probably be in 2B or 2C, or one of those 2 places that we have here. It'll automatically decide where to create one and will drop in another machine pretty much like this, except it will be here. And if you need more, it will be here like that. That's what you will expect to see, so that it will be load balancing across multiple machines in 3 independent availability zones in the Oregon cloud. We'll call this M2, we'll call this M3. And all of these things are in the Oregon cloud. That's what you will see when we grow. And so right now, we are not grown, so it is not yet there. But we want to load up our cloud, and that's when you will see growth happening. So loading up is the next action we want to do when we will go to that machine right there and load it up. I have this, I have this example where I have a, no, not that. This one is a load command I want to run. So I will already put that in our notepad here. I want to run that, but I want to understand before I run as to what is the scaling policy that we have in place. So we have our auto scaling group also defined. And this group defines the policy which will be used to grow or to shrink. If you remember this discussion here, in the case of Netflix example, we were discussing the idea of scaling, and we were talking about users, or rather more movies coming in. As a result, you need to have more of these machines to handle the added upload traffic. If there are lots of movies coming in, you need to grow. So that was the trigger to kickstart one more machine, grow up, or rather I should say grow out, because we are growing out as opposed to growing up. And so when you have not many movies coming in, you need to shrink back in. And the shrinking will happen based on a trigger. Now here, the trigger for growth and trigger for shrinking was based on the queue length or height of queue. How many items are there waiting for processing to finish? The goal was to finish it down to 0. So that our work is done. When the work is done, these machines can go. And that was the goal, the trigger behind this scaling, the trigger. So we want to understand our trigger in our example. What is our trigger? In this example, the trigger is driven by the scaling policy. And we have two policies to scale out or in. Let's go first look at the scale out policy. Now I use the word scale out versus Amazon uses the word scale up. So that is something to understand very carefully, that they're talking about the same thing, although I don't like their choice of words. I like my choice of words better. When I say scale out, I mean scaling like this. And when I say scale in, I mean shrinking like this. That's what I mean by out and in. But when I say up, scale up and scale down, when I'm doing this action, that is scaling up to me. And when I am going the opposite way, that is scaling down to me. So this is up, this is down, up and down. That is how I think. Amazon doesn't think like that. I don't care. I just want you to know what I mean and what they mean. And so when I mean scale out, they mean scale up. This is what I don't like about the choice of words, but it doesn't matter. Doesn't matter. So when they say scale up policy, they actually mean scale out policy. So this up word I don't like, but nobody cares about me. Just want you to understand that there's a distinctly different meaning that I have versus what they have. So the scale up should be labeled as scale out, and the scale down should be labeled as scale in. But that's just how I see, but whatever. So just understand that they talk something different than I talk, but we both mean the same thing. We are really talking about this. This. That's what we are talking about, not the change in size. Okay, having said, let's understand their up policy, which is basically out policy, the out policy. Now let's read that very carefully, because that's what we will actually trigger. The policy will be triggered like this. It reads, simple scaling. Execute the policy when something happens, when the trigger happens. When the trigger happens, when does it happen? It happens when, first of all, this long complex name, whatever that name is the name of the policy. And it breaches the alarm threshold. The threshold is triggered when the CPU utilization is more than 90 for 2 consecutive periods of 300 seconds. That's a convoluted way of saying that your CPU is hot for 10 minutes. right? 2 periods of 300 seconds, meaning 5 minutes. And so if you have more than 90% CPU for 10-minute period, or rather two consecutive periods of 5 minutes each, and then you will trigger the up policy, which is actually an out policy. That's when that triggers, the action to be taken is add one instance S. This S is, you get that. It's actually a typo. Add one instance. And then wait for 60 seconds before allowing another scaling activity. Wait 60 seconds. So let's draw this in a picture. The idea would be that you want to grow out and you want to trigger. You trigger when you have CPU percent. CPU percent utilization is currently like 0% right now, but it is going to grow. And then we will see that the CPU percent is high for a period of 5 minutes, another period of 5 minutes, and another period of any number of minutes. And so at this point, something will happen. It will trigger. What will trigger? It will trigger creation of a new machine. The idea is that you have to breach the threshold of 90 or higher for 2 consecutive periods of 5 minutes each, and then a trigger happens. This trigger will create a new machine. And then you have to wait for 60 seconds. 60? How much time? It's a 60 seconds before another scaling trigger. So 60-second wait. My question to you, why do we have to wait 60 seconds? Why is it important for us or any policy to wait for 60 seconds after creation of a new instance? Why is that important? So new machine gets created, you wait 60 seconds before you kickstart another policy. So why is it so important to wait?
Maybe to give the new machine time to register and the load balancer to catch up and everything like that?
Yes, that's one of the things. The other things that this thing takes care of is hysteresis. Hysteresis. Let me just type the spelling of this, hysteresis. I think hysteresis is spelled as hysteresis. Yeah, that's the spelling. So if you look at this picture, there are various illustrations of hysteresis, but the correct picture I want you to think about is this. And as opposed to this. This is a classic magnetic hysteresis effect. But that's not what we are talking about. We are talking about this. So when you have such an illustration, you want to actually introduce a delay of some amount of time before triggering the next policy. And so same is true in the other direction. When you want to shrink, you want to also introduce another delay like that. And by introducing this delay, what you're really avoiding is flip-flop. Meaning quickly create, destroy for no reason. You have to have a solid reason to create a new machine or to destroy a new machine or destroy an existing machine. If you don't have a solid, valid reason, there is no need to do. And if you actually do it, you are creating a flip-flop situation where you are accidentally, for no good reason, just boom, start another machine. Why did you start? No idea. I just started because I got a metric saying kickstart a new machine. So I kicked. And then the machine hasn't caught up. And that is why you're deliberately introducing the 60-second delay, or rather, in other words, deliberately introducing hysteresis into the system to avoid the flip-flop problem. That's what's going on under the hood, is you're introducing this delay to account for what Kenny just said, is to cut down on unnecessary flip-flop by introducing hysteresis into the system. Hysteresis can be a good thing and a bad thing. Mostly it is bad in magnetics, but it is a good thing in because it causes energy loss in magnetism. That is what is the general connotation, but in our systems thinking, this is a good idea. We don't want immediate triggers. We want it to happen with a slight delay to account for any unnecessary flip-flop actions. Okay, let's go further and put some stress to actually evaluate the policy about, we have to breach this alarm threshold. I want to breach it, meaning I want to put this stress for 90% or higher for 2 consecutive periods of 300 seconds each. So I will structure my command like this. I'll say sudo yum install stress, which I already have installed, and I would like to stress my CPU. And how many CPUs I have? I think I have 1. Let's go check how many CPUs there. HTOP will show you how many CPUs I got. I got only 1. So it's a small machine, and T2 small. So it's a 1 CPU. And then in that machine, I want to run a timeout of 660 seconds. So it will stress the machine out, and then we will run the stress for slightly more than 600 seconds, because our threshold is 2 periods of 300. So it's 600 seconds should do it, but I'm adding a little bit more than 300, rather a little more than 600. That's the command I want to run on this machine right here, like that. And I will, boom. And it says doesn't recognize CPU option because of the fact that we don't, maybe something is wrong here, or typing wrong, or what? Let's see. What? Sudo is not necessary. Stress CPU timeout. So is it dash CPU or what? Maybe it is dash. So stress is the dash CPU. Okay, dash CPU. Fine. It's not just CPU. It's dash CPU. So we will do it like that. We will say dash CPU dash timeout. Oh, there's a copy paste issue. Okay, you have to write like this. So I think a copy paste problem. Dash timeout, and off it goes. So it's 5:42 right now, and we'll run a stress on that machine. So the machine is kind of stressed out right now. As you can see, if I open another terminal and try to go to that machine, SSH, and try to EC2-user at IP address, try to examine the CPU consumption on that machine, you will see that it is kind of loaded up. You can see that in multiple places, but one of them will be the machine itself, because we have installed HTOP on that IP address. So we'll copy that IP, go to here, examine what HTOP tells us, and you will see that the machine is loaded up right there, 100%, stressed out. That's what we wanted. So we are having a nice, decently stressed out machine right now. This machine is under stress because we created it at 5:42. Right now it is 5:43. So in the monitoring tab of this machine, you will see that the CPU utilization has suddenly shot up. You can see that this spike happens, and it is currently at a value of 88.83%, but soon it will go 100 and peg it at 100, because that's the idea. If you look at this for the last 15-minute period, it has gone up, and it will stay like that. Let's go watch it in the next few minutes to see what this thing will actually do. And you will see the trigger action. The trigger action will happen, and I'll show it to you when it actually triggers. It will trigger exactly at about, say, 5:52, approximately that time. Right now it is 5:44. So in a matter of 2 consecutive periods of 300 seconds each is when we expect to see the auto scaling group, scaling policy, scaling up, meaning scaling out policy will trigger, because that's the policy in place. So it will take that action to add one more instance, and you will see that happening at 5:52. And maybe it's a good time to take a break at that break right now, because we have to wait and watch for this trigger to happen. So we'll do that, but we will start a break timer. And when we come back after the break, we should be able to see the trigger kicked in. And that's, but before I start I already started the break, but I just want all of you to remember that there are no sessions. I don't know if you're gone for the break. Let me describe this after the break. There are no sessions next week because I'm out. But I will describe that once everybody is back from break also again briefly, so that you don't show up and I'm not here because I'm not here. You know that it is not news, but I just want to point out. Okay, so I will walk away from the computer. I will come back in a few minutes, and we'll watch the auto scaling action live happening. Hey guys, checking if you're back.
I'm here.
Awesome.
I'm here.
So the idea behind the stress that we are running must have kicked off already. So let's go check whether I have a new notification email from Amazon that they have started a new machine for us. So let's go find out whether we have an email from them. Apparently not yet. So let's go see Amazon. Did you actually create something for us? Is there a running instance? Only one running right now. Okay, let's go measure the machines monitoring tab and see whether they actually notice a two consecutive periods of 10 minutes each, 5 minutes each, right? Let's go find out. And so in the time window here, I don't correctly see a 10-minute period quite yet. I see that the percent is 100. At this point in time, the time is 12:43 at that time instance. And then right now it is 12:53. It's just about ticking the 10-minute clock as seen on the monitoring tab in CloudWatch. Right, this time instance is showing us a timestamp of 12:43 a.m. UTC. And this time instance right now is 12:53. So it's just about to reach a 10-minute threshold or approaching that time window when I'm expecting it to kickstart a new instance. So I'm hoping that it will, which I'm pretty sure it will. There's no doubt about that. Let's also see the launch auto scaling group configuration to see if the policy have any triggers already. So let's see if the monitoring tab shows us anything. No. What about activity? Okay, I think it did. It did something. Let's go see what it did. It said that there are two instances running right now. The desired state is 2. The minimum number is 1. Maximum is 3. The initial state was 1, but now it is 2. That means we now have one more machine running here. And it is probably coming up or already initializing right there. And that machine is in new creation. And it was created as a consequence of our load that we are putting on this machine right here. And it is constantly stressing out 100%. And as a consequence, we have this new machine constructed. Let's go read what actually happened. So we'll go and read our auto scaling group activity history. And at the bottom, you see that this activity happened at 17:16, which is like the time of creation of the first machine, the very first one. You can read the activity here in the cause described here. And it's actually very nicely written descriptive language that we should read. At the very beginning of the setup, that's when it describes what it did. So at the beginning of the setup, at about 5:05 timestamp. No, it's not 5:05. It is the timestamp at 00:16. So it's at 5:16 p.m. Pacific time, which is 00:16 in UTC time. A user request update of auto scaling group constrained to minimum of 1, maximum of 3, desired of 1 was created. Now, changing the desired capacity from 0 to 1. We change our desire from 0 to 1. And as a consequence of the difference between the actual and the desired, the actual capacity was increased from 0 to 1. Because the desire was increased from 0 to 1, That was the initial request to create an auto-scaling group. We changed our desire from 0 to 1. And so as a consequence of that change in desire, at this timestamp, an instance was created in response to a difference between the desired and the actual capacity, increasing the capacity from 0 to 1. This is like the first time the first machine was created. That was the action. The cause is described right there. Next one is the second successful event, which is a different cause. So let's read the cause. This cause is different than the first one. The second cause we have up on top is that at that time, which is about 5:52 p.m., which is a few minutes ago, a monitor alarm in the state alarm triggered policy, that policy number. It triggered that policy. The alarm triggered this policy and it changed the desired capacity from 1 to 2. Now, why did the alarm trigger? The alarm triggered because we are pumping the CPU 100% for more than 10 minutes. So as a consequence, a new instance was started in response to a difference between the desired capacity and the actual capacity, increasing the actual capacity from 1 to 2. So it kicked up a new instance, started a new machine, and now we have two instances showing up in service. They are these two, and one of them is in 2A, the other one is in 2C. So we saw that the machine that got created was this one. This created here, and it was incorporated as a part of the load balancer network. And so now we have these users they're able to share the load among two different devices, the machine here in A and the machine here in 2C. This is the M2 machine in 2C. It did not use this one yet, but if you load up this machine also, it will see another machine create here, 2B. It will pop up if you decide to go that direction. If you load up that machine also, or if you do nothing, then like leave the machine up at 100%, the machine here at 0%, the alarm will not trigger because the overall CPU consumption is below 90%. The trigger policy requires us to look at the policy. It says the alarm will be triggered. No, not this policy, this policy. The alarm will be triggered when it is CPU utilization number metric is more than 90 for 2 periods of 5 minutes each. That's when the alarm will trigger. Now, if you have this one at 100, this one at 0, alarm will not trigger. For the alarm to trigger, you need to load up this guy also, M2, the newly established machine that we now have. So we can go that route, but that's kind of futile because you already got the point. So I'm not going to hit that second machine with some stress. There's no point in doing that. You already understand the idea. Instead, what I will now do is see the machine disappear by itself. How will I do that? Simply making sure that I'm not stressing out this machine. So I will quit the stress activity. By the way, it already has successfully completed in about 11 minutes. The stress has died down. So this machine is not under stress right now, which means it is at 0%, close to 0%, which means this machine, if you look at the monitoring tab, the stress has gone down. You can see that boom going down like that. And it is close to 0% all the way, starting from this timestamp, which happens to be 12:54 p.m. UTC, which is 5:54 right here in our time. So at 5:54, we'll give it roughly about 10 minutes from that point in time. And as a consequence, what do you expect? What do you think will happen in 10 minutes from 5:54? So we had something here at 5:16. We created first machine, and at 5:52, We created a second machine automatically because of 100% CPU pegging for about 10 minutes or more. And then we have that back to 0% at some point. What was that point in time? The point was this timestamp, which is 1254. So at 1254, which is basically 554, it was 552. We started the action at 542, and it triggered, the machine triggered at 552, and then in about 60-second delay and some extra delay for some reason, don't know why, but there is this trigger action happened where the CPU is 0%, and it is going to be 0% for next 10 minutes. And then you will see another trigger happen. And at that action, what do you think will happen in roughly about 10 minutes from this timestamp, which is 6:04. At that time, what do you think will happen?
A machine's going to get created?
Create? No. The machine is not at 100%. It is 0%. M2, 0%. M1, 0%.
Okay, but I thought it was going to go up.
Yeah, my arrow direction was bad. I should draw like this. Yeah, some activity will trigger at that time because we have both of them are 0%. Right? So let's go read the policy again. Right? You see that the peak here started at 1243 and it went all the way through this window, and then a new machine started. Similarly, if you now look at, in this period, if this period starts from here and you keep going like that for a certain amount of time, roughly about 10 minutes, something will happen. Let's go identify what will happen by reading the policy. So we'll go auto scaling group and read the policy. And this time it is not the up policy, but the down policy. In my language, I call it the shrink policy or the scale in policy. So let's go read that policy. This is what the action is expected to happen in 10 minutes from this, from this point in time, from the 0% action. There is a 0% load on M2, 0% on M1. Both of them are idling because our stress has died down. So it is 0. From this point onwards, which is at 6:04, something is expected to happen. Let's go read the policy now. The policy is simple scaling. And it reads, execute this policy when ASG demo, CPU alarm low, some number, breaches the alarm threshold. CPU utilization is less than 70% for 2 consecutive periods of 300 seconds each. For this metric, auto scaling group name, web server group, whatever the metric number is. For that metric, the CPU utilization should be less than 70% for this amount of time. If that happens, then a policy will be executed. Now, what is the action taken? Remove one instance. And then wait 60 seconds before allowing another scaling activity. So this remove one instance action is expected to happen in about 10 minutes from 5:54 because the percent consumption of CPU is less than 70% for more than 10 minutes, which is a fact of life. As a consequence, you already notice that the machine instances are already killed out. The desired is 1. This flag is showing that something is happening, some activity is happening. So let's go see the dashboard, and you will see the dashboard in EC2. We have only one machine running. One of them was terminated. It was terminated for a reason. The reason is the policy kicked in. If you go here you see that the machine is going down for power off, and it was disconnected because the machine was shot dead. Who killed it? Let's look at the auto scaling group and look at the activity history. And it is the third activity history shows you what actually killed. You will see when you read it. The cause of termination. Here it says, terminating EC2 instance, that number, at that time, which is at 6:03 p.m. Pacific time. This is 6:03 Pacific time. A monitor alarm, that alarm name, in a state alarm triggered this policy. And that policy changed the desired capacity from 2 to 1. We don't need two machines because we can do with one. So let us change the desire. Desired capacity goes from 2 to 1. And therefore, since you change the desire at that time, which is whatever that time is, an instance was taken out of service in response to a difference between the desired and the actual capacity, shrinking the capacity from 2 to 1. And this particular instance was selected for termination. So the M1 machine was killed. The M2 machine, this was killed. And so that machine is gone. And now only M2 is functional, which is what we have. So the picture now looks like this. M2 functional, again at 0%, because there is no load, because there is no customer. You can put load and you will see some machine popping up somewhere. M3, M4. Forget numbers. That's not the idea. Some machine will pop up somewhere in one of those three locations. 2A, 2B, and 2C. Undo, 2A, 2B, and 2C. Three availability zones. A new machine like this will pop up if you add load, and a machine will disappear if you remove load. That's the concept of auto scaling in action, live. Questions about this thing? Well, no questions. So let's go proceed further. What I would like to do is to basically revert whatever I did in this CloudFormation business. We have created a stack called ASG demo, which we are running right now, which is using the CloudFormation as a templated design. And we have built a bunch of things, and we have created a VPC and created resources, auto scaling group, launch configuration, all the things that you saw. We kicked in some load, and we saw grow, and we saw shrinkage and all that. So I want to now get rid of all this. So it is easy to get rid of things by just going to the stack and say, you delete the stack. So you select that and say action, delete the stack, and the whole thing will disappear. So yes, delete, the whole thing is dead in a matter of few minutes. That's the easy part. So you have a design in hand, you call it the JSON file that we used, and you just delete the whole thing in one shot. Say, I use my JSON, you apply, and you have a design out there in the cloud. And then you say, that stack that you create, you destroy it. And then it disappears. Simple. The same thing we can do in a generic open source tool called Terraform, which has similar structure, but it is more flexible in that it can handle multiple clouds, and that it can be stored in a Git repository where you can have multiple related things together with your other things that you keep for your applications, for your services that you maintain. And then you take that folder and say Terraform, apply. And when you apply, it creates a cloud. It puts your applications in place and goes live. And when you say Terraform, destroy, it destroys the whole thing. It's gone. That's the beauty. That's what we will do in a subsequent exercise. But before the exercise, I want to remind you, before I forget, that we do not have, and I think this should not be a surprise, but I just want to let everybody know that I am not here, so that we have no sessions next week. Just want you to remember. I think many of you joined a little late. So just want you to remember that today is May 4th. We are running the session right now. The next session is May 14th. There are no sessions on May 7, 9, and 11. Please remember that. Please do not show up in a video conference because I'm not here. Because I am going to Hawaii in my 25th wedding anniversary next week. So I am not here, which means I am not on a Zoom conference. So please don't expect me. I hope this is not a surprise. Was it a surprise to anybody? I think you knew that. Okay, just make sure that we are not having a session on 7, 9, and 11. Instead, we are meeting on the 14th the next time. So just remember that. Okay, now back. We will see that the destruction is happening and it should have been completed by now. So the machines will be all gone. There are no running instances. It is all killed off. The load balancer has disappeared. Yes, the launch configuration, auto scaling group, all of them have gone. That is exactly what I expected, which is what this tool has done for us, is destroyed the stack that we created using a JSON file, and that stack is disappeared because we don't have it anymore. So the whole thing that we created using that setup, that JSON file, is eradicated. That's an easy way to handle these apply and destroy actions in the context of the cloud. And every big cloud company, every big cloud, major cloud company will give you such a method. Basically have some kind of a structure to store the data in a file, and then you use that file to apply to the cloud and they will recreate whatever you had. That's this CloudFormation tool as an example. And let us now see how much time we have. 6:15. So let's see what we can do in the remainder of time. I think we can discuss another case. By the way, this case discussion versus the other ways of handling, which one do you find more interesting? Do you find more live examples or more discussions of cases of actual companies? Which is more interesting? I just need to know. What do you think you like more? This idea of the Netflix discussion as an example with other companies, other implementations, or would you like to have more examples of more tools? We'll do both, but I just want to get your preference.
No preference. Both are pretty good.
Both are
like
good.
The Netflix example.
Okay, good to know. Good to know. Good to know. So we'll do, given the time we have about 45 minutes left, I would like to actually do a fictitious case study. Fictitious, totally fictitious, meaning it is fake, but it is still interesting. So that's what I want to do. I will quickly take a look at my notes and then discuss that. Okay, so here we go. The fictitious, totally fake idea, like this is made up. And I'm making it up as I go. The way I would like to describe this idea to you is in like few words. I will call it video 911. That's what I would be talking about. You know what 911 is. I'm extending the idea of 911 with a video capability. So you have the regular method of calling 911. You make an emergency call in an emergency situation, and you are able to talk to the emergency response center. You already know that. I am extending the idea with video capabilities in hand. The reason is that, by the way, this is all made up stuff. There is no such thing. But I'm going to assign a new project. So imagine that the president of US gives you unlimited budget. And gives you certain assumptions. And we'll keep on adding to the list of assumptions here. But one of the assumptions is everybody has an iPhone in the US. The second assumption is everyone has unlimited data. We'll keep adding more assumptions as we talk, because this is a fictitious case. We have to assume a lot of stuff, make up stuff. But the goal is to implement video 911. My question to you would be, how would you go about doing these things? Like, what would you think? How would you think about the considerations, the assumptions, the budgetary requirements, which I just throw out because it's unlimited. We have enough money. And we have enough, everybody has iPhones, they have FaceTime, they have unlimited data, and it's all paid for by the government. So we now have to work on a system that will implement V911 in the cloud. How would you go about even beginning to think in that direction? That's the question. I want to have that discussion with you. So I want to see how you think. And what would you ask? What question would you ask? What quick calculations would you make? Where would you start? What would you do? How would you begin thinking about what does it take to run such a service, to construct what are the pieces of puzzle that you need to solve? I'm deliberately keeping this a little bit open-ended to understand how you think, because that's the primary idea, is to understand how you think about a fresh new problem that you have never heard of. It's just thrown at you, and so you get a new problem, a new budget, and some assumptions to work with. So I want to understand your thinking. So help me understand. Where do you begin, if that's the goal? So imagine a scenario would be that, a person in emergency picks up the iPhone and makes a FaceTime 911 call as opposed to a phone call. That's the scenario.
Well, my first question is, are we the ones providing the video and voice service?
Okay. So who provides the video service?
So, so this is going to be for all of the US population, right?
Correct.
So, first I need to figure out how many users we're talking about, right? So find out the US population.
Yes.
And then start probably getting some metrics on how often are folks calling 911.
Yes.
Start like understanding who are the users, right? Or who are the users, because this is free, right? So there's no customers, there's only users.
Correct.
What else?
So I think the first step is just to get all the data about the existing 911 service.
Yes. And then divide that into like a US, imagine this is the map of the US. So now you have, states, and you have, counties within the state. And, if you look at our state of Washington, in here we have the King County. But that's not how these 911 services are divided, by the way. So if you really look at how 911 services are rendered, they are catered to by their own emergency systems, as opposed to not delineated by county boundaries. I don't know exactly how they do it, but it's probably done based on the emergency response 911. You'll do some Google searches to find out how many centers And oh, there is a 911.gov. I did not know that. Okay, maybe that's a good site to study. And so here are the resources and about the program. And that's, I did not even know about this thing. Okay, so maybe this thing will give us some ideas about what documents they provide in terms of what's the cost, what's the funding, what kind of tools are available, what kind of data do they provide, and how do they divide this user base, because you have to really understand from a segment of population in a region. For example, if I live in Sammamish, and when I call 911, the call goes to Redmond, and we have a fire department that is maintained by Sammamish, but it's not operated by Sammamish. It's operated by East Side Fire and Rescue. And that is a separate team from somewhere else that doesn't belong to the Sammamish city. And it is coming from some other location. It is probably a couple of other cities, including probably Issaquah and maybe other locations outside. So that group of cities together are handled by the East Side Fire and Rescue. And they cooperate with local police authorities and then are able to handle the idea behind rendering services of emergency nature to the population in the city of Sammamish, for example. So Redmond has their own Redmond Fire Department. They have their own. But this East Side Fire and Rescue office seems to be in Redmond City, which is different from the division between Redmond and Sammamish is different. So the bottom line is we have to identify how are these regions divided in terms of the 911 region. This is one region, here is another region, and you have to identify where are the people spread out, how are the regions covering the entire US population on a map practically. And in various regions, say in Florida here, or in Massachusetts here, on Washington here, you have to identify what are the pockets, how do you geographically divide the entire nation into parts where you can decide that this geographical area will be answering customers from that location, from this location for 911. And you will handle that phone call traffic. And then you will dispatch appropriately the medical emergency, or whether it is a emergency of other type, or maybe it is police emergency. So depending on whatever that situation is, you will dispatch appropriately fire or ambulance or police, depending on the nature of emergency. Now, as a beginning step, what I would suggest that you would do is you pick one or two pilot areas and identify how much of resources are needed for such a pilot to work. You have to understand what would be a typical implementation of such a program be. For example, you have to estimate bandwidth required for a simple 911 FaceTime call. Let's say this person calls that person on FaceTime. So you have to understand how much bandwidth is needed for this pipe, for a FaceTime communication between this and that person, and make sure that that bandwidth can be handled by multiple people simultaneously calling a center. So that bandwidth estimation has to be accounted for and adjusted for, and you have to basically make sure that your systems that you're deploying in the context of a cloud setup, where lots of people will call a emergency situation in emergency center at the same time, your system should be able to handle the incoming calls. Otherwise, it's a bad system. So now we'll measure. What I did actually for real is I actually turned on the metric to calculate the bandwidth needed for a typical FaceTime call. And it turns out it's about 2.1 megabytes per second is the amount of bandwidth needed for an ordinary FaceTime call. So if that's the bandwidth expected between two endpoints, and you have to estimate how many people will actually call at a given situation based on statistical data available for that region from past regular plain old 911 calls. You will have to estimate that and then come up with some metric to come up with a machine infrastructure in a cloud location, which will actually be able to receive these calls coming in from a bunch of people at the same time. And you have a large collection of machines here that will be able to handle your traffic, incoming traffic. You can visualize the same picture like we had before here to handle the scenario in a sense that this picture also applies to the same idea. In some sense, in here, we are not uploading movies for processing, but what we are really doing is handling inbound video calls. So the picture illustration will change a little bit in the sense that we will have people like these calling 911 FaceTime into the system. And system on this side is not an upload server, but an emergency response server. And that server is basically keeping track of incoming calls, receiving them, answering them, and presenting them to operators on a screen where they can actually see what is going on here. Whatever that person is going through right now will be able to see and will be able to interact with that user. At the same time, keep track of every single activity here and record the entire conversation and put that in some kind of a repository. And these emergency responders should be able to respond to the actual action by not only talking to the person, but also looking at what may be happening in their FaceTime call. That is what will be the enhancement to this fictitious service that I'm talking about. So the idea would be something similar to this, that the EMR people, the people who will respond, will not be needing to have an iPhone there, because that's not what this system will expect. Is the other endpoint is not an iPhone, but a system that talks to the iPhone and actually records it in form of a DVR, like digital video recorder playback, stores that video here, and also lets the emergency response people interact with that person dynamically as they call in emergency situations, and also record it for playback for future and for archival purposes. Now that setup that you will need to create in these kind of machines here will require, by the way, will you be using Spot instances in that setup where emergency responders are handling? Spot? Tell me no answer, please.
What do you mean by Spot?
Okay, so the Spot instances are the instances that will disappear because you're not paying them full price.
Oh, okay.
Right here, the machines that you get here, EC2 machines launch an instance, and the machine instance that you launch, you can select it to be a Spot instance that you will get for cheaper price.
Right.
Right? The question is, would you actually get Spot machines here for DVR setup for emergency response?
Yeah, you can use it, but you can put a limit, like, you can put a condition.
Don't.
Oh, don't.
Because I told you we have unlimited budget.
Oh, yeah, you're right, yeah.
And so that is one of the reasons. But the more important reason is not that we have unlimited budget, but the fact that it is an emergency service, and it is going to be stupid to actually have a machine die on you while an emergency call is active, right? That will be a stupid idea. So that's the reason why you should not actually have a machine which is a Spot machine, because that will just disappear on you, right? It is cheaper, but it doesn't make sense to get a Spot machine here. Instead, you should get a dedicated instance, dedicated set of machines, or maybe on-demand price machines that will grow as needed and expand and be able to handle the incoming traffic. That is a critical thing to remember. Now, another idea that I want to bring up to you, which is in a different picture, is this idea about about the fact that you've seen utilization numbers. You saw me when you start a new machine, it is typically at 0%. You saw me when I add up some load on the machine, it goes to whatever number you want it to be, 100% or whatever number. You put some load, the CPU consumption goes up. Now, on an ordinary basis, on mainstream production workload that you will typically see in your companies, what do you think is the right utilization percent? Is it 0? Is it 100? What is the right amount of utilization number that you think is the right way of using our resources? Like you saw this action to grow triggered at a 90% for 10 minutes or more. And you saw the shrink trigger at 70% when it 10 minutes or more. That action happened at these numbers. So keeping it at 0% is a waste of money. Right? When you don't have any load on the machine, you are wasting money and the machines are running, and that's a bad idea. So my question to you is it a good idea to keep your machines running at 100% utilization?
No.
Yeah, correct. You're right. It is not. 100% utilization is actually a bad idea. You should leave some room for your process to actually handle. So an ideal number would be somewhere in between 80%, 85% optimally utilized for ordinary production usage. So you are not wasting money, but you are not bringing your machine down to its knees. So if you look at my machine right now, I am spending my CPU at about 165% on Zoom, 89% on Resilio, and like that. And I have 8 CPUs here, so there's not an issue, lots of CPUs. So I'm basically underutilizing my machine, but that's okay. If I run some stress on this machine, it will stress out and go up to 800%. And that is bringing that machine down to its knees. I can shrink my consumption by quicking, and that you will see this particular process will go away, and then overall my machine will run a little bit less consumption on the CPU. As you can see, this process will going to go away. I just quit that. Now, having seen these things, from a waste of money versus too much utilization, what is that right number? What is that optimal number for utilization of a machine for common production usage? And I'm saying it is 80-85%, because it is not too much, not overburdening your system, and you're not wasting your system either. So it's somewhere in an optimal situation. You're making full possible use of a machine that you have spent money on and not burdening it too much. That's what I would go about doing in the most ordinary cases. However, for the case of our 911 operations discussion, I just want to ask you this question again. For a 911 operation, what kind of utilization should you think is most appropriate? Is it 85? Is it here? Is it here or here? What number is the most appropriate number of utilization? Somewhere here or here or here for emergency purposes?
I think out of those three, it'd still be 85.
For emergency. Okay. I would argue that for emergency machines, the utilization should be 0%.
Oh, so ideally you wouldn't be using the service at all.
Correct. Now you get it. Now you got that. Now you exactly got that. That's the point I wanted to communicate to you, because this fictitious case that I'm bringing up is actually fictitious, but it drives those points which are very subtle, is to understand the fact that every load that you have in your company is different. Not every load is emergency load. Not every load is like grunt work that you can probably run it at 800%. So this is grunt. This is mainstream production. And this is emergency. And so somewhere in between, you can have an optimal number that you will come up with, which is probably appropriate for your cost model, for appropriate deployment for a given type of application. Is you need to understand what is right for that given type of application. And you don't want to be grunting 100%, which is a bad idea. Imagine if you have, these Sammamish East Side Fire and Rescue operation. They have 5 trucks, beautiful fire trucks sitting in Sammamish. I've seen them, and they are there. They look beautiful, red, and you have about 5 of them. And the truck drivers for the East Side Fire and Rescue are nicely dressed, and they are there every morning, and they come here and they shine, they clean their truck, and they make sure that everything is ready, and then they are doing nothing. And we have 5 of them. Each truck is probably a couple $1 million. Bet money on that. It's a very expensive truck. And these people are doing nothing. Is that a good idea? We have 5 of them in Sammamish. And every morning they come, they do nothing. They sit there idling the truck. Is that a good idea? What do you think?
Depends on the day.
No, on an average day. On an average day.
4th of July?
Yes, 4th of July is a different story. But on an average day,
Yeah.
is that a good idea?
Bad idea.
Is that a good idea to have these many trucks?
Not a good idea.
The answer is yes. And I'll tell you why. The answer is yes, it is a good idea. I would like to have these trucks sitting idle all day long, all year long, including 4th of July. And I will gladly spend my tax dollars on keeping these things functional, but not in use. Utilization number 0%. That's what I would like to strive for in my city, in my country, wherever we live. That's the goal, is to make sure that your emergency responders have nothing to actually do. You want to make sure that they are prepared to do anything, whatever it takes. But when it comes to actually doing things, they don't have any work. That's the setup you want to live in. That's what an ideal emergency situation is when you have an emergency service, it is fully available and highly underutilized. That's the nature of emergency services. Your goal is to keep it at 100%. You don't want to actually load it up. You don't want to have a disaster. You don't want people call 911. You don't want people to have fire or other medical emergencies or police disasters, or not police, but theft or other situations. You don't want those problems in society. So that's why you have fire trucks ready and police ready, because you don't want to use them. So it is actually a good thing. And yes, I will gladly spend my money and let them clean and shine and do nothing all day long. That's exactly how I would like to have it functional all year long, year after year, forever. That's the goal. It's a stated goal. I think you would agree with me. Something's happened on 4th of July, and for that situation, we have these trucks. The reason we have them is that we can handle emergency when it happens. So on 4th of July, something happens. So this truck gets dispatched. So now we are at a 20% utilization. And now something else happens. So this truck goes away, and this truck goes away, and this truck goes away. We are at 80% utilization. 4 trucks currently in action. Okay, that's a scary situation to me already, because I have only 1 truck left. And my 4 people have gone. I have only 1 person sitting ready and idle. That's a scary, scary situation. 1 more phone call, and then I have nobody. That is 100% utilization. So then in the fifth phone call comes in, this guy goes away on duty. And now we have nothing. We are at 100% utilization. And now is the scary time. You have another phone call, the call number 6th call comes in. Now you're screwed. You are actually screwed right now because you can do nothing. Now that is a bad situation. We don't want that situation. That is why we strive to make sure that our utilization is 0%, ideally all the time. That's not possible though. So that's why I believe that we should keep these trucks available and ideally unused, nice and ready and everything, but no work. I hope you got the point. So on the contrast to this is the other extreme. The other extreme is 100%. That is also a valid situation where you need that 100%. When you have something that is, if you have read the book, the Goal book, it describes this A, B, C, D, E, and F. I think I gave you this example of 6 people, 6 primary school kids, and you are going to chaperone them from here to the top of the mountain, and you have to go all the way to the top, and you have to go the fastest possible way. And this guy is the slowest on your team. So what do? You put that guy on the top, and then other people. And then you connect them with some kind of a bungee cord and let them go in that direction. Our goal is to make sure that this person who's the slowest, he never stops. Meaning he is actively walking uphill 100% of the time. The moment he takes a break, you make sure that he walks again. Don't let him stop, because he stops, the whole thing stops. And that is not what you want. So in situations in companies where there are situations like that, by the way, there are situations when you have to produce some result for the customer in the fastest possible time, but there is this dependency, this dependency that you have on that the person who may be a person, who may be a machine, who may be some process, who may be a team, depending on whatever it is, which is called the bottleneck. So the bottom line is to make sure that the bottleneck in your system should be utilized at 100%. And if it is not utilized at 100%, you are screwed. You're screwed because you're wasting money, because your entire pipe, all these other people are waiting, idling, not for a good reason like here in emergency situation, but for a bad reason that your F bottleneck is stuck doing nothing, which is a bad idea. In that case, you have to expand your capacity, or maybe fire the guy, or do something else, find a substitute and replace with something else to remove the bottleneck. And then that new bottleneck, whatever you have, wherever you have, should be used at 100% all the time. If you're not doing that bottleneck 100%, your system is screwed. It's broken. Fix it. And everything else in between these two scenarios, which is the emergency scenario, and on the other end, the bottleneck scenario, everything else falls somewhere in between. What is that right number? You decide. Maybe this is the number. Maybe it's a different number. That's not a magical number, but it is somewhere in between the 0 and 100. I just gave you two extremes to help you think about any situation in general. In bottom line, if it is an extreme situation of either these two types, emergency versus bottleneck, you adjust accordingly. And most of the time, things fall somewhere in between. What is the right number? You decide. What is the right trigger percent? Like, is it 90%? Is it 70%? What is the right trigger that you will actually trigger to start a new machine or to destroy an existing machine? That number is something that depends on your business situation. It does not depend on Amazon's policy metric. These are made up numbers. Made up. And so they decided to put 90 and 70 to basically arbitrarily somebody chose that. That's not realistic because cannot be realistic, but there is no example. We stressed out the machine by running artificial stress. That's not reality. In reality, you have other things that will drive performance. And those metrics are very rarely percent CPU. They're not. In fact, the more people will call 911, it is likely that the CPU will grow higher, but it is also likely that the CPU will not meet 90% ever. Because most of the traffic that you see in a video call is actually on the network. So the network bandwidth may be the constraint. So maybe you want to grow the bandwidth needed or available bandwidth to account for incoming network bandwidth. And maybe that becomes a metric to think about in case when you have an emergency service situation where lots of people may be calling you. This is conceptually similar to people uploading videos, except there is no video file, but it's a FaceTime call. So the network characteristic can also play in the picture. There are other things that may get involved. For example, if it is not a 911 call, not a video FaceTime, but something else of some other nature, the bottom line essentially drives down to the point where you have a auto scaling setup of some sorts, and the actual action may not be upload services, but maybe something else, and that something else will actually dictate what is coming in and what more of it is coming in. So more of same coming in, and you need to handle this load. To handle this load, you have to really account for what triggers will be used in scaling this system automatically. The triggers basically boil down to many things. Like it can be any business thing. For example, CPU, memory, disk, network. These are some of the common things that you will see at the machine level, very easy to measure, really easy to measure. You just put some monitor metric and trigger your auto scaling policy and you're done. But that is not how you should actually measure and actually trigger kicking in a new system, because these are, although very easy to measure, CPU percent, memory consumption, network consumption, disk, very easy to measure things because they give you ready-made tools to measure that. You can see that there is this service available in every cloud, and here the service is called CloudWatch. And other clouds, they have their own services like monitoring service. And so you can see that these metrics are available, but they may not be relevant. The point I'm saying is these metrics are, although easy to measure, the thing you should really measure, which is really very hard to measure, is customer happiness. That is the real metric that you want to have. To measure, are the customers happy? Great, we don't need another machine. The customers are going to be unhappy a little bit. Okay, add one more machine and make them happy. And now they are not unhappy, so they're happy again. So you keep that like that. That's the concept, which is really hard to implement. It's almost impossible. Let me be honest. It is impossible to measure this thing. But ideally, that's the case I would like to get. But it's not possible. How do you measure customers' happiness? So if I go to, say, Facebook, and if I see that the Facebook is not scaling for me enough because it is not loading for me right now for some reason, so I'm an unhappy customer. It took me like 3 seconds or 4 seconds for it to load. And I just became unhappy because it was not good enough for me. So how will Facebook know that I'm unhappy? They will not. Maybe they can. They can measure the time it takes for me to load the application, and thereby estimate on an average how many people in which locations are actually facing a lot of load times, and adjust that appropriately, and maybe add some machines or more infrastructure resources in that geography so that Facebook loads appropriately. Maybe that's a metric, but that's not the right metric in every single situation. So we have to really come up with what I call proxy metrics, which indicate customer happiness. So you have to calculate that metric on a case-by-case basis and come to a close approximation that measures customer satisfaction, and then use that metric as a proxy. Like the mention that I just did of Facebook load times. It took me about 3 seconds to load up Facebook on a fresh new browser page. Now that was low from an experience perspective and expectation perspective, because Facebook has been recently, in the last so many years, reasonably fast. When I load Facebook, it just loads up. But it is now taking me 2 seconds roughly. And if you look at this site, it is pathetic. It takes it also took 2 seconds. It is slow. But you know what? I'm comparing a gigantic company with a very, very tiny company like this. So there are not many users. There are not many users. There are maybe 20 users, 25 users right now on this site, versus there are, I don't know how many billion users on this site. So it's a different game. But what I'm saying is, you have to understand what proxy metrics can you use to come up with a measure of satisfaction of the user, and use those metrics as relevant to decide when to scale your applications and grow one more or shrink. That decision has to be made using a proxy metric, such as this one is one example. Another example that I think we had before was the example of how many items are there in the job queue. Is the queue down to 0? Not yet. Okay, we have lots of items in the queue. Let's add some more machines here, and then make them finish off the work and bring the queue down to 0. So that our queue is 0, we are happy. Our internal team is happy because our processing is done. So our queue is empty, then our customers are happy, internal customers are happy, so we can get rid of these machines. And that's the proxy metric we have used in this example. So it boils down to customers deciding in form of some kind of a proxy metric to tell you when to trigger an auto scaling policy. And these examples that we just saw, which had a 90% or 70% triggers, they are kind of made up. Like these numbers that you saw here and here, somebody made it up and put that in the policy. It has no meaning to anything. There is no customer. We are just fictitiously running some random stress load and testing out some academic thing, which is pointless. But that's a beginning step to understand auto scaling, automatic scaling, and see how we can put that to real use. Questions are welcome. Let's see. So what I would like to do next time when we get together on the 14th is understand how does, let's see, let me see what I have in agenda. Let me go there. So bring my notes from the last time. That will help me give you an idea about what we want to cover. And the thing to look at is winter 2018. That's where I have little notes on what I want to cover. For example, right below, it mentions discuss Netflix case discussion, and then the auto scaling live example. V911 discussion. You can see what I did cover the last time we ran this boot camp, and I will follow the kind of sort of same way in this time. And so we will cover cloud architecture, Kubernetes. We have to understand what Kubernetes is. We'll make use of it. And then we'll do the hard way exercise, which is, by the way, a really, really hard exercise. Just bear with me on that because it will take time. It is hard. And that's what we will do. We'll further extend our Kubernetes exercise in using the next time. In this location, we have fairly nicely documented the Kubernetes steps written down here in this segment. I'll put that link for you. That is already available. So I'll put that in Slack chat. You can read ahead if you like. It's a fairly easy to follow, but fairly extensive write-up about setting up your own cluster, understanding what a node is, understanding what containers are. So we'll go through these steps as we get together on the 14th of May when I return back home. I am not here on 7, 9, 11. Those days I am out in Hawaii. And 14th, that's when I will be back. I just want you to be aware of that. And with that, I stop recording. Questions are welcome.